In this video, we're going to talk about arithmetic sequences and the recursive and explicit ways of representing them. An arithmetic sequence is a set of terms changing by a constant difference. If you think back to elementary school, you looked at a list of numbers and had to figure out a pattern. That's all an arithmetic sequence is. So if we look at this example, we see the set of numbers, and the pattern is we're adding 6 to the previous term each time. Now when I say term, I want us to think of it in terms of I have a first term, a starting term, and we're going to say, okay, that's my first term, 1. My second term, third term, fourth term, and so on. These terms and how we're going to talk about them usually is represented by the variable n. Now, when we have our sequence, in earlier classes you were able to express it in what was called a now next notation. That's where we said the next term is equal to the now term plus 6. So the next term is equal to the now term plus 6, which makes sense in this context. The more formal way is called a recursive notation. And recursive notation uses what's called subscripts. This is where our n is going to come into play. So we have a term at a sub n. N is considered a subscript, which for what we're talking about means the number term. So if I were to say a sub 1 is 2, a sub 3 would be 14. So to write a recursive notation, I would say a sub n to find my next term is equal to the previous term, which can be represented as a sub n minus 1, plus 6. That n minus 1, if you think about it saying, if I have that term 2, the previous term is 1. 2 minus 1 is 1. But when we have our recursive notation and someone says, well, what's the 50th term? We would have to find every term from now until the 50th. And that takes too long. So that's why we've developed an explicit type of notation. Now this explicit type of notation also begins with a sub n, but the difference is we use our starting term or our initial value, which for this sequence is 2. So we have an initial value, and we're going to add to that initial value. So since our constant difference here was 6, we're going to add to our initial value. But to determine how many times we need to add 6 to our initial value, we use the term number. So to find the next term, we have to use the term previously, which is n minus 1.